raining on a Friday night. It was so cold outside. So I'm going to talk about two very different studies. One is about modeling conversations among students, and second is looking at international study of about 500,000 students. I really appreciate help from my research assistant, Choi Yik-ting, who's been phenomenal. So there are four major challenges in education as specified by the US government. First, how can we adapt to students and help them improve their learning experiences? Second, how can we assess students' 21st century expertise? Third, how can we get, store, analyze, and share data in real time, really large data sets, what we call big data? And lastly, how can we create online or hybrid learning systems that are better, that encourage best instruction in half time and half the cost? And so they created this because they set out these guidelines for deciding how to allocate money in grants. So if you're interested in applying for grants, try to put your projects into one of these four areas. So most of my work is in big data, although I touch on all the other areas mostly through collaborations with friends and colleagues. So today I'm going to talk about big data studies at two very different levels, or really cutting across multiple levels. There's the analysis of group conversations, which is sort of a combination of meso and micro. It looks at individuals, but also in terms of talk. And then I'm also going to look at half-million students' mathematics achievement. And that's very macro, different countries, and then the meso would be individuals. And I'm going to argue that there are two microeconomic mechanisms that drive these inequalities. So let's start with the students working together on problems like this. So we typically have groups of 3 or 4, and in that class, they'll work on problems like this texting problem. Under the universal texting plan, each text message costs 10 cents. On the other hand, if you use budget texting, it only costs 1 penny per text message. We have to pay a monthly fee of $18. So then we ask each student to think how many text messages you send each month, which company will cost less for you, and our primary question of interest, how many texts you send so that both plans will cost the same amount. So for students who are just starting for an algebra, this is a very difficult problem. There isn't a simple way of representing this for them. And so they typically try to come up with ideas and see if these ideas make sense or not. And this is what I call micro-creativity. So not surprisingly, groups that engage in these micro-creativity processes more often are much more likely to solve the problem. So the natural follow-up question is, what group processes are going to influence these micro-creative processes? So, quick definition, creative processes have two major components. They have to be generating new ideas, or they're justifying the utility of these ideas. And so typically people talk about big C creativity, which affects the entire society, like string theory or invention of a computer. There are also individual creativities where I might be just figuring out, okay, my faucet's broken. Like, how can I fix this without having the appropriate tools? So that'd be very individual creativity. Probably won't affect the entire society. And what I'm going to talk about in my study is micro C creativity, which is things that happen at a particular moment in time. So it stands much lower for micro C creativity. So I'm going to look at how two different types of categories affect micro creativity: social metacognition and rudeness, or pace. So we know that metacognition is monitoring and control of one's own knowledge and actions. So natural social corollary, social metacognition, is group members monitoring and control one another's knowledge and actions. And we know that in tons of studies, we look at people's individual metacognition, and it's generally horrible, like among little kids, among teenagers, among adults. So it might be possible that social metacognition can help alleviate this problem. So social metacognition, I'm going to look at two different aspects: questions and disagreements. Questions indicate knowledge gaps. People, when they ask a question, they're basically saying, I don't know something, and this is a gap in my knowledge. And I'm also inviting you to help me fill out that gap. And so the person asks a question expects other people to either provide new information, create a new idea, or use old information to help the person understand the situation better. Disagreements are also important because they identify obstacles. And my present obstacle encourages group members to overcome it with new ideas and justifications. And I'm also going to look at phase rudeness, and I'm going to look at root disagreements versus flex disagreements, excessive agreements, and also commands versus questions. So you probably heard saying say face or people face is friend. That's about a person's public self-image. So when people disagree, they can either disagree rudely and attack the other person's face, or they can disagree politely and help the person save face. So let's take an example. Someone says 5 plus 7. I can disagree rudely and say, no, you're wrong. It's 5 times 7. And this rude disagreement makes it much more likely that previous speakers will retaliate, could lead to an emotional argument, and so that makes it a lot less likely they'll have new ideas or justifications. And if it's really extreme, it might just tear apart the cooperation. On the other hand, I can disagree politely. I can say, if we're computing distance, we can multiply 5 times 7. So here, this is polite in several ways. There's a hypothetical situation. If distance is the error way, there's no you, so there's no direct blame. And the use of the we shows shared positioning and common cause. So polite disagreements tend to save the speaker's face, help someone listen and understand the obstacle, and try to overcome new ideas or justifications. No matter how polite people are, disagreements are still disagreements. And you're basically saying something that someone's wrong in some way. So if you're not comfortable with the other person, you don't know them very well, you might just not disagree. And you might just agree just to maintain your social relationship. And so if that happens, then the wrong idea sort of stays within the conversation. And you might be building on top of wrong ideas, which is very likely to lead to a correct solution. And last we have commands versus questions. So whereas questions are relatively polite, giving you an opportunity to help out in some way, commands are basically saying, I'm higher status than you are, I'm going to tell you what to do, and so I'm demanding that you do something, implement a particular idea of mine. And so this is much ruder, and because it affects people at the emotional level, they might be distracted from solving a problem or feel very uncomfortable and be less likely to participate. So this is my overall theoretical model. We have social metacognition and phase rudeness variables that might affect new idea justifications. We also add all sorts of control variables like math grade, peer friendship is how many people nominate me as their friend, gender ethnicity, and we also take group means and standard deviations of these within the group. So I collected data from 84 ninth grade students in US City. They were working in 21 groups of 4. I talked to a teacher to make sure that they weren't very close friends within any one group. It was the first day of algebra and also the first day of the group work. This is actually the beginning of a really long intervention, helping them to work together in groups. So they hadn't been prepared to work together, and they worked on a problem for 30 minutes. We videotaped every single group and audio tapes every single person. And then we transcribed it, and 2 hours coded each of the students 3,296 terms. And Krippensdorf's alpha showed high iterative reliability across all our dimensions. So here's an example of a couple of kids talking. Jay says $180. Ben says if we multiply by 10 cents, don't we get 180 cents? Ben's doing 5 things, at least, at the same time. He disagrees politely, provides information, the information is correct, he justifies it, and he asks a question to invite further participation. So this is sort of a quick comment on roles in groups. Often a person is engaged in multiple roles at the same time. So that particular comment by Ben helped me think about how to code all the different possible terms of talk. So I have a 5-dimensional framework: evaluation of previous action, knowledge content, validity, justification, invitation, participation. So when someone says something, I can either agree, yeah, I can be relatively neutral. I didn't quite hear you. What did you say? I can ignore the topic entirely. Is it time for a snack yet? And I can either disagree politely or rudely, as I mentioned earlier. In terms of knowledge content, it could be a new idea that hasn't been expressed before. It could be an old idea that someone's talked about, or it came from a problem, or from a teacher or a textbook. Or they might not be talking about the problem at all. That would be a long task. They can be right or wrong. They can justify their answer or not. And they can also invite people to participate to different degrees through commands, very strongly, a question, more invitation of light, They're simply making a statement and not related by participation at all. So for each of these dimensions, we have decision trees. So sometimes it can be very complex. So here, statement, command, question, there are a lot of subtleties. And we want to make sure we capture each of those subtleties to put them in the right category. And so the quality of the coding typically depends on the quality of the decision tree. And so because we have decision trees that are very intricate like this, very precise, we get really high reliabilities above 95%. So in a transcript, it looks something like this. The person says something or does something, and we have columns for each of the variables. So this is what our database looks like. And on top of the term level variables, we also have individual variables and group variables that we can add as variables as well. So unlike most standard statistical analyses, we're going to incorporate time in this one. So what J says in the very last row depends on who J is, depends on who his group mates are, but it also depends on what previous people have said. It depends on what Eva says in the previous row, I call flag 1 or minus 1. What Ben says, 2 turns go, 3 turns go, so on and so forth. So I invented something called statistical discourse analysis to model these situations. And there have been a lot of critiques about why you cannot use statistics to analyze conversations, and they're all quite valid. So there are actually about 12 major issues with analyzing conversations. And so we pretty much have to solve all of them to get anything published. And so if you're interested in this, I can talk about this in great detail later. One of the things that statistical discourse analysis does is it statistically identifies a critical moment in a conversation. So this is one group, and we did this for every single group. And we're looking at how often they create new ideas. And so at the very beginning of this group, they read the problem, they have some ideas, and they're running along very smoothly. Then someone mentions, oh, this reminds me of my trip in Alabama this summer. And so it crashes down, they go off task. Someone mentions an idea here and there, but doesn't get taken up. Then at one point, someone draws out a really good representation of the problem. People look at it, and you pop up to say a lot of ideas, some right, some wrong. Then, at this point, someone does computation, and they hit multiply on the calculator instead of plus, so you get some huge number that doesn't make any sense. And so they're struggling to try to figure out what's going on here. And then, at some point, someone has a really different way of looking at the problem, and they solve it. So in this group, we have 1, 2, 3, 4 breakpoints that divide the entire discussion into 1, 2, 3, 4, 5 time periods. And so what we can do is we can model what happens in each time period separately. It could be that the relationships between our independent dependent variables are the same across all of them, or it could be specific to particular time periods, and also be specific to particular people. So this is what our overall results look like. We try to predict what's going to affect the likelihood of a new idea in each turn of talk. And that depends in part on peer friendship. So people who are nominated to be friends more often, they have higher peer status, they're just more likely to talk and express their ideas. So black indicates a positive relationship, they are more likely to express their ideas. Root disagreements, on the other hand, are less likely to be accompanied by new ideas. So red indicates a negative effect. And thicker lines indicate larger effects. So you can't really see very well here, but there's a slightly larger effect of root disagreement compared to peer friendship. When people agree, they're also less likely to come up with new ideas. Someone says, we should do this, someone says yes. We can also go back in time, the previous turn, and the root disagreement makes it much more likely that the next person is also going to really disagree. And so a positive times a negative is a negative, so that's a really strong negative effect. It's very unlikely you can have a new idea after that particular sequence. Likewise, when someone really disagrees, the next person is less likely to agree. And so negative times a negative is a positive. It's a very small positive effect there. And then root disagreements in the previous turn also have a separate independent slight positive effect, which is adjustment for all the other effects. So in order to figure out what's the impact of root disagreement, you have to basically add those up. And if you know that the next person is going to really disagree, you only go through the first line. And so depending on the situation, you go through a particular sequence. We can also model if there are differences across groups. So in groups that do not solve the problem, their response to root disagreement is much worse than groups that do solve the problem. And you see this through the strong negative effect of an interaction term, a group disagreement, and groups that don't solve the problem. And we can also see whether it has an impact, whether the local time context has an impact. So if we go back in time, and the previous speaker has a wrong idea, and the next person really disagrees with it, then the last person is much more likely to have it correct and have a new idea. So the actual impact of group disagreements depends on the exact specific situation. And since we have numbers connected to all of these thicknesses of lines, we can compute what that impact is for each situation. A few other effects, commands, as we expected, are less likely to provoke new ideas. We can also model justifications at the same time. We can have any number of outcome variables in these models. Pure friendship also increased likelihood of justification. Polite disagreements also tend to accompany justifications. Commands are less likely to do so. And here's an interesting result. Commands are often followed by polite disagreements, which then leads to justifications. And this shows an important status effect. People who are high status tend to make commands. And then people who are low status, they're probably going to disagree politely, if at all. And they often tend to explain why they disagree. And this helps explain the next relationship, which is people with higher math grades induce other people to give justifications. So if you just looked at this at the group level, you look at the average math scores of the students. Groups of higher average math scores tend to have more justifications. But it's not the people with higher math scores that are producing them. It's actually the people they're talking with. At least in this study, when people with high math scores talk, they don't really justify or explain why they're doing things. They just think we should do it. So it's the people who are lower status that tend to respond with justifications. So this is an important place where looking in great detail at the terms of talk gives you a very different result than looking very coarsely at the group variables. And we also have a difference for groups that don't solve the problem. Math grade has a negative effect on justifications. So we see that there are important group and time period differences. I mentioned group differences already. For each time period, we estimated what the impacts are. And so they range from -2% to +1% unsuccessful groups, and -1% to +3% successful groups for persons mathematics grade. So here are some direct implications for teachers. We want groups to be more creative in the micro level. We don't want them to be giving commands all the time. It's rude and it makes it harder for them to come up with ideas. If you're in disagree, it's probably better to disagree politely rather than rudely. And after someone really disagrees, you really don't want to disagree rudely in turn. That makes it really unlikely you're going to have a new idea. There are also interesting implications for researchers. This statistical method allows us to identify those critical moments in a conversation that radically change what happens afterwards. And so we don't need to rely on humans to make subjective decisions. We can analyze with a computer program. We also know that often the effects are different across people, time periods, turns of talk. And we can model that now with statistics. And most studies look at only individual actions. And now we can look at sequences. So it's not simply one action that makes a difference. It's often a sequence that makes a difference. And it's a new method for modeling conversations. This method actually was designed to analyze conversation, but has much broader application. It basically asks the question, what major momentary events will affect people's behaviors over time? During classroom conversations we've seen. We can also apply to online conversations in a pretty straightforward manner. But we can also look at individuals. We can model one person's problem solving if we think aloud. We can look at infants learning a new word. And we can go much more broadly. We can use this to analyze basketball games, how basketball players are interacting with each other, and see if they score or not. We can model stock market transactions and even wars. Because they're all essentially about this issue of how events affect people's behavior over time. So on to my second study. Now we're going to a totally different level, looking at 65 countries. And this is a common question. Why is it that students in different countries have different test scores? Is it because some countries are richer? Is it because some countries are more equal? Or is it because of cultural values? So we test all these hypotheses in one study. Money is a very clear answer. The more money you have, the more learning opportunities you have, the more you learn. More books, more computers, all of that's really helpful. So that's pretty clear. Lots of studies have shown this. And our results support this as well. Something that isn't studied before is inequality. Does inequality affect people's learning? And so we have family, school, and segregation types of inequality. Some families are richer than others. Some schools are richer than others. Some of the teachers are better qualified, more educated, better trained. So those are pretty much sad ones. There's also schoolmate inequality. So in some countries, like the US, there are a large portion of rich kids go to schools only with other rich kids. Poor kids go to schools with other poor kids. That actually isn't true in most of the world. In most of the world, like Finland, South Korea, Japan, rich kids and poor kids are mixed together in the same schools. So when they're mixed, you have much greater schoolmate equality. So how is it that inequality affects learning? I think there are two possible mechanisms that we can think of that strictly in terms of economics. In the first case, imagine you're a rich parent. You spend lots of money on your kids, you buy them books, computers at home, and so when there are issues like public school spending, you're thinking, why should I pay for other people's schools, books and computers? So in very unequal countries, the people at the top have a really strong incentive and power to influence those decisions. So they tend to lobby against public school funding. This leads to lower school resources overall, because their own kids go to schools as well. And so when there are few school resources for everyone, you expect learning opportunities to go down and learning to go down. And second case, inefficient allocation of resources, it's also called diminishing marginal returns. Maybe get a couple of bottles of water. So let's imagine that Jim is really thirsty. And so I'm going to give him 2 bottles of water. And so he's so thirsty, he finishes the first bottle entirely. But then his thirst is quenched, he doesn't even bother touching the second bottle of water. So the second bottle of water that's untouched has a lower value than the first bottle of water. And this is what we call diminishing marginal returns. The more you have an object, the less valuable later instances of that object are. And so we see this very clearly in terms of this curve. This is a logarithmic curve. And so if you give an extra book to a poor student who has very few books, it's worth a lot to that student. But let's say a rich student has like 1,000 books. You give an extra book to a rich student, it's probably going to have a smaller impact on that rich student. And so when we have greater inequality, we're essentially moving resources from poor students to rich students. And the impact of each resource is less. And so this is inefficient allocation, and people might learn less in countries that are less people. There are also tons of cultural values that we tested. And I won't talk about this very much because you'll see why in a couple of moments. So here's our basic model. How much resources, inequalities, and cultural values affect student learning, specifically in mathematics. So our 2 mechanisms are, when you have greater inequality, there are going to be fewer overall school resources, which typically have a positive impact, and you have inefficient allocation resources, which can reduce student learning. I didn't collect half my kids' data myself. That's the Organization for Economic Cooperation and Development, Program for International Student Assessment. I was actually part of a team in Hong Kong, and we collected data from Hong Kong students, but there are 65 teams of researchers working in their own different countries. They put the data together. So I looked specifically at the math test data. There's also reading tests and science tests that you're interested in. Each student took math tests, they answered questionnaires, as did principals. And questionnaires were forward and backward translated into different languages to make sure they're consistent. On top of that student data, I also looked up data from the World Bank, economic data for each country, and also cultural values data. So I integrated all this into a giant database. The analysis is also pretty complicated. So if you're interested, I can talk about this after the talk. But the results are pretty much what you expect. If you're in a richer country, richer school, richer family, your schoolmates are richer, you're going to learn more. Also, inequalities of any type make it less likely you're going to learn as much. The effects are small, but since you're just moving money around, you're not adding resources. These are pretty large effects, I think. And the mechanisms that we expect also operate So GDP cheating is family income inequality, inequality of students, teachers with university degrees in schools. That tends to yield fewer teachers with university degrees who enter the education system. So that's an indication of fewer resources. The law curves I showed you earlier show up in the GDP, gross domestic product per capita, or country income, and also education materials at school. So both those physical objects, entities, show log effects. And we often see this in general, that when you talk about physical objects, physical resources, they tend to have log effects. So these are mechanisms I talked about earlier. We do see evidence of this. And this is why I can talk about cultural values. After you take into account economics, cultural values have no impact. And a lot of the effect that people find in cultural value research is because they're looking at countries that have very different economic situations. On top of this, I did a lot more analyses where I broke down the sample in subsamples. I took the top, the poorest 20% of the students in each country, poorest 10%, poorest 5%, and not surprisingly, get the same results. What's interesting is that if you take the richest kids, it's also true. Even the richest 5% suffer from inequality. So maybe if you're in top 1%, inequality is in value, but even for the top 5%, you're still worse off in a less equal country. And also, for achievement, you get the same results as well. So across all these subsamples, these results are incredibly consistent. So, there are practical implications. You want to increase school resources, you want to try to reduce these inequalities, and you want to integrate students as much as possible. You want them separate rich kids and separate schools from poor kids. Thank you.
Hail to old Purdue, our friendship may she never lack.